interactive sessions that we are having in this course. Uh, let's see what I can cover this week today. Compaction. Cover. Compaction of soil and ectostress power. Check the title of the lecture must be MVP because researchers to and part of data. Yes, basically, we can say that compaction is first. And with the soil ground input. It's a very common method that would do whatsoever for any type of construction. That is why we certainly keep becoming more detailed. Otherwise, there are other grounds to be factors. But also to understand that why we need to. Because before you want to construct your building or image structure, it the area, the land on which you have to build it, it will not depend on like how you want it and everything else. Like this is the natural process. You cannot be like this process. For example, I have a plot of land, but found out that the patient of capital of the soil, the strength of the soil in this plot is very weak. But I want to raise a structure there. I want to raise a house. There are some methods that we use to influence the strength of this soil. Compaction is to study there because whenever you start texting, you might have seen that is in leveling of the land and then you apply rivers. At least uh, at least when you have 50 centimeters, you take and level the land before construction. You level the land, you level for construction of roads, the construction of buildings, etc. Now, what common principle is first of all, we had talked about limited density. That if I have a soil deposit that has inherently the nature that it has a void ratio between E minimum and E max. And when it's transferred to, let me say, the The natural state of the world is somewhere there. Let me say there. For the government. Yes. So the very good news are the rules the world. I want to influence this and because what I will do is I will try to reduce the void ratio. Reducing void ratio means path the soil in a better pattern. So the granular material will improve the pattern of the soil uh, or increase its strength so that it has a better um, low transfer mechanics. If there are two voids, then low transfer mechanism will be. What we do is we are trying to increase the void ratio. So, we are trying to reduce the voidness and reduce the density by compacting. Compacting basically just means that you are taking the material and you are applying load over it so that the pattern becomes denser. So the density will increase, the voidness will increase. That is the, we can say, uh, broad concept of compaction. If we talk about it in a little more depth, it means that this is in your phase diagram. This is solid, this is water, and this is air. What compaction means is that you decrease, you expel the air from the void, you reduce the volume of the voids itself because their volume of solids or volume of water will not change, it will remain same. The voids are the, so we can say that compaction basically expulsion of air from the void or reduction in volume of voids. So on this basic level, this is what we need to understand when we are studying that. So this is concept behind whatever child value. So we're talking about problematic new material and what are the potential problems in face inside of new material. Software will have a very low strength. They will build on it. We will see excessive settlements. We will see defective settlements. We will see very low permeability, which means that when you study compaction for the time, so they say that if the permeability is very low. Takes a very long time for set compaction for consolidation to take place. That is the final settlement to be over. It takes a very long time. Since have low strength, high compressibility, high decompression potential, this is very important. Um, Low permeability, we'll talk about this also. Organic soil is again high compressibility, large creep formation because with what is creep? Basically, creep is after so you have the soil. It, it as we said that So voids cannot be zero. There have to be some minimum voids for it to be classified as zero. Let us say that the minimum voids that can be that this soil can achieve, minimum void ratio, is something like this. So the change in voids, volume of voids, initially when you start loading compaction, there will be an immediate decrease. Then in the next phase, what we will try to do is we will try to do consolidation. Consolidation will take some time. It will be called primary consolidation. After this primary consolidation has taken, this primary consolidation takes place under a specific amount of load. After a very long time, when this going to consolidation is over, what happens is that you have the. I would like to ask first, am I speaking too much ahead in the curriculum?
What way?
Am I speaking too much ahead in the curriculum? Because I don't know this uh, if this is a supplementary class or this is your main your technical class. Because I don't know if I have to assume that some other things you already know.
Well, it's not very early. You do what you are doing. Ma'am, it's not very ahead.
Not very.
Ahead.
About topics that are too ahead of the curve is difficult. Okay. So I was saying that primary consolidation. After primary consolidation is over. That's this is the maximum volume of voids you can reduce generally. After that, over a long sustained, over a prolonged sustained load, what happens is that the microstructural properties of the soil start degrading frequency. There are very slight changes in the structure of the soil. It is not because of change in the volume of voids. But till now, compaction, consolidation, everything is because of the change in the volume. But after that has been achieved, the minimum void, maximum change in void which has been achieved. Then internally we can say a chemical type of characteristic type of change starts to occur in the soil, which results in leaf recovery. It is not because of change in the voice. It is because of change in the volume of the solids. Now, leaf deformation is, as I said, because of the change in volume of solids. Now, organic soils have very high content of degradable matter. So at the start, if you have a high volume of solids, after some time the degradation will take place and the solid will be converted into gases and liquids. Then you will have a lower volume of solid. So as compared to conventional soils, which are very, very low weak or secondary from consolidation, organic soils are significantly large. Secondary consolidation because of the presence of the organic. Then you sands, again you have liquefaction potential. and high permeability, high erodibility, and silts also have high erodibility. Erodibility is irritability is because you don't have any positions in sand particles. You know, if you take mostly sandy material, you take it to your hand, it will fall. So the same thing will not happen with clay because clay has inherent position. Sand does not have that. And because of that, due to forces of nature like wind or water or anything, sands get very easily eroded. Silt is also a fine grained soil, but its nature is more similar to sand, as in it does not have the position because the position of the place comes from the clay minerals. The chemical bonding between the minerals causes like it is like spongy type material that soaks that has a water retaining capacity. But since and sand, they do not have these clay minerals. So they do not have this solution and they are high erodibility. And because of this lack of solution also they have this detoxification. Detoxification is like I can say you can say something like quicksand. So those will be there. So what happens in liquefaction is soil that we have under cell weight, this is stable. Okay, under the cell weight, let us say that the cell weight of soil is 17 kilometers. So when I walk over it, it will generate the required resistance to my uh, any weight that I provide. But in the sandy soils, what happens sometimes is that if it is very, if it is saturated, and you have very fast loading, rapid loading, dynamic loading between so something like when I'm walking, just my load will be formed by the water, and then slowly the load will connect it with the soil scale. But in clays, the problem is that it's transferred from the water to the soil scale. It takes a long. But in sand, it is very quick. It's not a problem. But anyhow, if you provide dynamic load in such a way that uh, you don't give enough time for the transfer to take place from water to soil skeleton to whole this area in which we dynamic loading as in machine loading or quick loading takes this will behave as if it was a surface of water because that is what is retaining your weight down. It's not the soil. Soil particles are literally floating in the soil because the reaction they have a reacting force opposite equal to the weight of the soil. And because of this, what happens is that anything that is buried down in like a very pipeline, it will move up. And anything that is resting on the surface, it will move down. So you see, if you see here, until the loading is until the loading takes place, this soil has behaved during the loading, during the earthquake, has behaved like a flooding, like a quicksand or water. And these guards, they have moved down. Uh, and after the loading is over, it's again behaving as a soil. Now, as you can see that it feels like uh, yeah, because it's something that is very common for like cohesionless materials. So the buildings, they will just like as if they were on water and they will start monolithically moving like this. You will not see that breaking or something else happening. Monolithically, the things will uh, move inside the soil. That is liquefaction. Okay. And then expansive soil, because large volume drain, this is more for clay soil. Because as I said that because of the clay mineral, it behaves as uh, sponge. It has high water retaining capacity, and when it retains this water, it increases its size because the water has to go from the swells. And when it's dry, it shrinks to a very large extent. So what happens because of this? We get desiccation taps, something like this. These are desiccation tracts. You can see that the volume decreases so much that we get these cracks. Uh, so this is not good if you want to do construction over complex. Is not a good sign. It will mean that if you lay a foundation on this soil, it will always be with the wetting and drying cycles. You will have you will constantly have this buoyant and like uplift and buoyant force on this foundation and then on good purpose. Okay, so this is about what is the problem, what are the problems in natural deposits where you want to do construction. Other thing is that fill, as in we also materials uh, for construction, not construction on the materials. That is one thing in soil mechanics. The other thing is using these materials for construction of structures like embankments or retaining walls. So if I want to build an embankment, and because it takes millions of tons of material, and the most easily and cheaply available material can be soil, and different like we have some specifications for that, right? But okay, so what are the problems in using individual materials for fill is if you have dredged material. Dredged material is something that you take out from the ocean, especially, for example, if you have a very long coastline. And the defense strategies, what we want, is defense all as well as economic strategy. We want large ships to reach the coast of the country. If the ship is very large, it will be very, the portion of the ship below the water will be also very large. So as we go towards the shore, towards the land, the water gets shallow. So large ships have to um, unpack all the materials that they have and goods that they have. They have to unpack it in at an intermediate distance from smaller ships. So that is a lot of logistic, very logistically that is a little difficult. So what many well, at many places, especially around Mumbai, dredging practices are done so that the level of so that the depth of water near the coast is increased. So that material that you get out from the sea bed is very obviously it has a very high content, it has low strength, and it has high compressibility. Usually, you think about it, what is the type of material you will find in the sea? It will be all the rivers are coming to the sea. They are bringing alluvial material. It will be clay. It will not be sand, or it will not be glass. Somewhere in the streams you may find gravels, but until by the time it reaches the sea, it is very finely. It is very. It has a very fine with it. So it will have high water content, low strength, and high compressibility. Reclaimed film can be anything on which you have done some construction, and now you have demolished that construction. Recycled material, now you know, recycling materials can be different types of materials that we talk about. For example, sometimes we use the concentration like for fly ash or any kind of particulate material like long tables, even MSW. So, certain material inside solid waste and bio waste, byproduct. They are the fabric. So we talked about compaction. Compaction means the press the soil particles together expelling air from the wells. As we said, the consolidation also leads to reduction in the wells, but here these are not the same because here um, the reduction in volts is due to expulsion of water as a threshold for expulsion of air. Now, why that is different is because when you are expelling water, the load transfer mechanism is different than when you are expelling air. Because air will not support any of the load that you are applying on the material. All of the load will still go to the soil. But during consolidation, when you are consolidating, the load that you put after material, first it will go to the water, and then it will go to the soil. And that transition, you have to study that how this is called excess flow water, like a pressure is developed inside the soil. Uh, Initially, when all of the water, all of the load is taken by the water, the neutral water, water pressure that we already have, we get a reading of, we can say, if you put a standpipe in the soil and you have a particular neutral water loading, and then you remove that soil, you will see the water level rise. There is an excess water pressure. That is because of the immediate loading of the soil. And with time, consolidation takes place and the load transfers from the water to the soil level. And this excess pore water pressure dissipates, decreases until it is excess pore water pressure, not more water pressure. excess pore water pressure is different than pore water pressure. Okay. So the excess pore water pressure becomes zero. Um, so compaction is to increase the shear strength of soil. The purpose of compaction to increase the shear strength of soil, to decrease the future settlement of soil, and increase its permeability. Because larger the air wall, larger the volume of noise, we have higher density. So soil compaction we can do using static rollers. We can use dynamic rollers. Okay, this is something that we need to for. Let's talk about it first. When you say that I want to compact a soil soil, what you are saying basically, for example, I'm starting construction and you take out the roller, you start about the what how do you know how many passes of roller are required? How do you know what should be the weight of the roller? How do you know what should be the height of the lift? Like you level in lifts. You take, for example, 2 centimeter, then you roll. When you take 50 centimeter, then you roll. How do we determine these is that we go to the characteristic property of the material. Uh, we calculate the maximum derived density that the material can achieve at a particular water content. And in the lab, we do this test, we take this soil, we actually we calculate the maximum right density. And when we say, let us say that 95% of this MDD, I need to achieve 95% of this MDD in the field. So then I calculate based on that, and then I check from the compaction, I check the dry density. So it's about 95 of MDD, then you will know the compact. How do you know what is the maximum dry density? So basically, the relation between moisture content and dry density for the fine grained solids will look something like this. So if you have low water content, you will have like you can say that not the relation between gamma delta and W. It is the relation between uh, what is the minimum maximum water content I will be able to achieve and what is the maximum dry density I will be able to achieve at different water content. For example, I am this doctor test in which we give loads of hammer to this material. And then we load the hammer to this material, the standard test 25 kilo into 300. Okay. So let us give that the material first had water content of 31. That will correspond to this dry density. After I did the test, then I have to check the dry density. Then I increase the water content and I calculate the maximum density that I achieve using the same compactive efficiency effort. And I can see that the relation between the maximum dry density I can achieve using the same compactive effort and what it is going to sum, right? This. And from this, I calculate the OMC, which is the optimum moisture content, that would be the optimum maximum consumption value. I take these values and I try to apply it to A. That is the basic 3 lines of compound. So here if you see, you will see different types of combustion here, or different types of tests. As I said, that or same capacitor as well. You will see this there. But what if instead of 25 blows, I give 3 blows? I will have definitely higher gamma T. I will have a higher gamma T. But usually for standard practice, we do the crop papers for a very specialized project like airport or defense security. We do heavy, most of heavy tractor, uh, heavy weight compartments. So in that number of layers are same, but number of layers are five. The weight of the hammer is more and the height of the wall is more. So we have higher factor as well. So we will reach higher dye density in the field. The type of soil type is that a well-graded soil can be compacted to a higher density. That is because it will have good factor. Okay. A low porous sandy silt that has poor gradation, its packing efficiency will not be that good because all the particles are of almost same size. So it will have larger voids and the dry density and compaction will not be that. This is the roller. Okay. So recommended type of roller, I just mentioned that vibrating roller is used for sands or cohesive materials because they feel dynamic load. It's kind of a dynamic load, and that results in a denser packing. You might have seen that if you have sometimes you have like the rice bowl or something and you tap it. If you have a container of rice, if you tap it, you will see that the level will go down. But because the particles will align themselves in a better pattern. So, vibrating roller will be first, less sweet food roller. So the vibrating thing will not work with cohesive foils because of the cohesive. For them, what we do is that the normal roller that we have small the roller. We will have small protrusions on this, and these protrusions will be something they will result in a higher pressure because we are using the uh, surface area for the same load. We will have lower surface area. The force that you are applying for the compaction will that is what we use for ambient soil. Results of the standard processes by the follow it. We have a model of how to choose experience. So there is a link the the- okay. So everyone to determine the maximum dry limit rate of transaction and the optimum logistic content. Calculate and plot gamma d versus transfer content for degree of saturation 8900 has been given to us that we have to define 7. So let's see what we have been given. We have been given volume of liquid. We have been given floating rate of the of soil in the world. We can calculate the bulk density. We have been given land capacity. You might learn that gamma D equals gamma B plus 1 plus capital. You can also write it like gamma D equals B plus 1 plus capital gamma capital over 1 plus 2 and gamma D is B plus gamma capital over 1 plus 2. With the right hand paper, you get gamma B minus 1 plus capital liquid. X and on itself side See, right? One plus this. Then we can calculate the by this. By density increase with yeah, by density. Right? Okay. Now 17.15 kilometers incremental it will be around 15.59, around 15.59 kilometers. And that are the values that we use in the recommended maximum there in the period of some profit that is 59%. Let's go in the graph. your answers. And I think content is good. It is the usually last and this is not the future. And then we are in the standard one. And after the people started doctor taking the sample, then checking the density at the time, the picture and the video. And then go, then after take out the yes. Actually, I'm here, Gamadi represents the country that we are already have. It is the maximum by unit rate of comparison of the method. Right. The second process calculate on the floor 100 versus 1 second for a pixel or surface in 80, 90, and 100. Given that USS define 7. So what we can do is this get the intimation, I'll get this voice that somebody is able to have. Otherwise, I will not be, I will not know that somebody has asked the question and which I was. So you're asking that the Dalton has played. As I said, Dalton does not have played. It seems, it may seem like it is a plain thing, but it is actually sandy and it is not a type of soil. It is just a condition that happens to occur at a particular given particular solution. If the soil has a particular type of gradation, it has to be sandy, it has to be saturated, or simply has to be saturated. And in that case, if there is a dynamic load or there is a hydraulic head that is causing the water to move upwards so that the sulfate of the soil is getting nullified. In that case, you will get this quicksand or turtle. So it's not a type of soil, but it is a condition that occurs when you are sandy soil deposed dynamic movement, saturated condition. Okay. So next thing we were doing was calculating the experimental new what government is. Now they are we know the government, we know the public. Now when you are saying that you want to calculate master content person will do a calculation for each calculation. But we just to take this less in this medical internet as in the without equal and be over x as we saw here comedy reports US comedy and that and that we calculate from there compared with the basic 100 reports plus 100 over plus W. Let's calculate plus calculation of 80%, 90%, for one year at different Saturdays. Let's go. That's the connection which can help on the back. It was a little bit limited at every morning, many people. It's a good rounded for the district. It is the different in fact, using that nothing just that's the one places, the degree of that. can calculate the consumption. For packets definitely. Value calculate the transaction. Right? That now we don't take the guidance. We take the policy. There is already model in that model. And in order to take the guidance, we have to write a page which is actually called a TV stars. Uh, so what we do is we take the guidance one principle because it is easier to just have to weigh the soil or the specimen. That's actually the limit. And then we divide by What are the question is? This is fantastic that we can do my problem of the different environment. Not to do the air right there, that better with the system. This is fantastic. So, we calculate basically what is the density. What is the we air very line basically. Like the 100% possible. Everything is right. It cannot mean that the material does not have rights. Still calculate that all of the words will be things with water, particle, individual, in the area ready. We will have a calculation that. That is, the zero error factor. So that grammar bill is fixed. Grammar bill is equivalent to zeros. Grammar W will run plus then your run plus with this. is it comes down and you're right. How this people come at the and the white races they have in the next civilization when not Rama Kali, but Rama Supply, Rama Supply, and the races. Particularly like Rama Maximum. I would like to formula for Rama form or white. Because there is a change. So high density means low volatility. Low density means high volatility. Same thing with the saturation. Not the same thing, but basically saturation is with respect to the whole white chocolate. As saturation increases, can assume that the saturation increases, we can do either between more molecules or maybe or related to animals are further one. I not it means what we can do add on with all having the factor. But that's the point of the They calculate the total stress in water plus the system. Total stress the pressure. So, I'm just telling it
Okay, ma'am.
about effective stress, effective stress over. Basically, we define stress as force acting over an area. It can be internal, it can be external. But if you say the force is not today, this is the area, and you can be applying load on the entire area. Stress will be stress is the internal stress which is generated through the application of the load. Now, because this is a force material, particular material, it will have particles. So, at any cross-section, what you can see is that this area is actually different than the area of the solid particle. So, what about these pairs? Will they, will these pairs resist the load and provide the stress? So, what we do is we have considered this uh, effective labor that results in effective stress, which is equal to the total stress minus the co-water stress. So while co-water pressure is the actually it's the equivalent minus 4. Let us say that the material is not saturated. There is only some water. So the entire area is made up of volume of solids, volume of air voids, volume of water. Some of the load is being taken by, uh, let's say, area of solid, area of air voids, and area of water. Some of the load is being taken by this, some by this, some by this. So the component of load taken by the solids will be like this way. Will be total minus the stress taken by water will be u dependent on the head or height of the water table or hydrostatic pressure because you know that water exerts pressure in all directions equally. So you know u and the resistance offered by air is very minimal. So this we don't consider. Otherwise, we could have had, if we had to liquid into the liquid, flow pressure of water, flow pressure of other liquid. So this would have been the effective stress. So the effective stress is the stress that is specifically carried by the soil grains, and the total stress is the stress that is carried by collectively by the soil grains as well as the earthworks. Okay, so if you need to calculate this, okay. From here, at A, let's say sigma total, at A, sigma total is 0, U is 0. Like this case. And we have come down to a height of 6 meters. Yes, you do. Right, this is 2.5 into 6. Since there is no water transfer, volume brighter, even will be 0, and the mother will be at the same issue factory sound, but it is below the groundwater level. So, and mentioning that the water contain the water the soil beneath the groundwater level will be it will have a submerged um, like, like, the gamma saturated is 9.25, gamma submerged and 25 times 10 125 minus 1 to the 130 will be the gamma submerged. So it will be 1.25 into 13. This one will be gamma matrix 10 into 13. The gamma dash will be subtracted and we have to add sigma b.
No, ma'am.